Get started. So today's conversation is really, again, building on some of the earlier conversations we had about exterior interior lighting design as it relates to the energy code. And we've been talking about this whole first half of the year, breaking up the energy code into different sections to correlate to different functions within the building design. Right? We talked about thermal envelopes, we talked about insulation, we talked about air barriers, fenestrations, doors, mechanical systems, and now we're going to talk about lighting systems. And so we talked a little bit about exterior a couple months ago, and now we're going to bring it back to this conversation to kind of build it into what'll be next week or in 2 weeks from now when we bring it back and look at it as from a plan review perspective. What do we need to look for plans? What and then after that, what are we doing inspection wise when it comes to this kind of subject? Now, you know that one of the biggest things I think is important for us to understand is that when we review or think about any building code, we always have to ask ourselves, what's that question of why? Why are we doing this? And that will better allow us to figure out how we accomplish that task in our building projects and what we're trying to review for. And when we think about that, we understand that the building itself, and especially as we talk about in the context of the energy code, whether that's the 15, 18, the 21, or the 24 for that matter, the building code is really focused on what I see is, or what I always highlight for us is these four concepts: the building thermal envelope, the mechanical system, the service water heating systems, and that power and lighting. Now, when we talk about these concepts, we normally, if we look at the evolution of energy codes from for the last 50 years, we see this primacy or this big use or reference to uh, the thermal envelope, right? That's the thing. That's, if there's one word that we talk about with energy code, it's always insulation. Hear it one more time, right? My kids even know that thermal envelope is the key word when you talk about the energy code. But that's because that's getting us to a place where we understand how we're going to use that system in relation to the rest of the building. At some point, when we look at the energy code's development, there is a place where, if you look at the 2027 code development process, they're not really messing with the envelope anymore. We've identified the envelope values are pretty much going to be what they are. We might fine tune some pieces, but really we're looking at an envelope that's going to be consistent because it's it's the other surfaces and systems within the building that's really where we use the power. We don't plug in our wall. We don't plug in our insulation into the electric grid. What we plug into electric grid is the mechanical equipment and the insulation for assists in that process. We talked about that before. What we plug into the grid and into this concept of energy conservation is the lighting, right? Now, the energy code goes to only address lighting. It doesn't get into how much does your TV use, how much does uh, your computer use, right? It's not looking at those types of use. It's looking at something very basic, right? And that's going to be the lighting considerations. Now, where does it go in 50 years? I don't know, and I don't want to pretend to think I do, right? But right now, what we're looking at is how do we use energy, and how do we connect that conversation. Now, when we talk about that, we always, in my mind, we always have to remember our compliance paths. Those compliance paths are really going to be important when we start thinking about what is the expectation for lighting and power related components and the energy code. If I'm following a prescriptive path, right, then I'm following the book. Now, last week we talked about prescriptive, we talked about the compliance paths. So very high level, if we talk about the prescriptive, that's do it the what the book says. And when we look at total building performance, that's that dollar and cents. How is this going to perform and what's my dollar annual cost to operate this building, whether it's residential or commercial. We get in the ERI, the energy rating index, or to the extent that we talk about another performance rating like I just lost the name of it. Energy Star, right? What we're looking for, or LEED or something like that, what we're looking for in those situations is a grade, an index, right? A rating that we can put on a building and say, hey, out of 100 points, you got a 60, you got a 50, you got a 30. Now, If I was in high school, and getting a rating, I would do great, right? Because 30 was a good number for me. Because in the energy code, the lower the number, the better. So when it came to, you know, uh, history writing or literature and history, that class I did not like, and so 30 would have been a great score for me, right? But in the energy code, that's a good score to get that low, right? 50s, 40s, that's where we're trying to target. The energy code says this is our target based on our climate zone. This is what we're trying to get to. But in those last two models, so when we think about this, the code says that we should provide certain documents and details on our construction documents. And that's where we get this. Oh, I went too fast. I used the wrong button. So that's where we get this idea that we have to mark down the equipment and system controls. Now we're going to look at residential first, have this residential conversation. Then we're going to break into the commercial, right? So for those of you that might be more interested in the commercial side of it, give me a few minutes and we'll get to it. But you'll see very similar concepts between the two, right? But the code says I need to provide equipment and system control information on my document. Now, if you look at what's in the 15 or the 18, what the way the energy, the entire requirements of Section 404 on electrical power and lighting systems, the way it was organized is we're going to have lights, right? It's very simple. We're going to have lights, and those lights have to be a percentage high efficacy, right? In the 15, it was 75%. In the 18, it's 90%. Of all the bulbs, all the fixtures that provide lighting in the design, they have to be high efficacy bulbs, right? And the only other requirement we have in the energy code for the 15 and in the 18 is that if we're going to have fuel gas fired lighting systems, that they can't have a continuously burning pilot light, right? So that if I've got that light outside if I decide I want to go with a real flame out by my, by my patio deck, that I actually have to have a connecting a firing mechanism. I can't just have that pilot light running constantly, right? Because that's just using energy when I'm not using the light, right? So that's the kind of the goal, the rationale behind where the energy code was going. In the 21, that's when we see a lot of these black lines, right? Things changed in the 21. And why did they change? Again, because we've realized it's not the envelope. Now it's time to get down to business and start talking about the thing that actually spends energy, use energy. And I always go back to this, and this dates me, and maybe it dates some of you, but I remember back in the 80s, in the late 80s, when the LED light bulbs came out. And we used to go and see the science fair. This was at Ace Hardware or a Handyman or Lowe's back in the day. You could go there and they would have those bulbs. They would have the incandescent bulb and the LED bulb. They'd be plugged in and they'd be on the spinning energy meter. Everybody remember the spinner, the dial that would run to show you how fast, how much energy was being used by the incandescent, and then you would turn on that LED and it would spin really slow, right? Because it was using less energy just because of what it was, right? What we've come to in this reality is we've reached that point where, okay, it's not just the bulb, right? We've got the best bulbs we can have. Now we need to start layering in some additional concepts, right? And so, and when we start talking about those things, what we've seen is the power and lighting has gone from 75 to 90 to 100%. I'm sorry, I totally forgot about this. I should add in the handout in case anybody wanted to follow along. But what we see over time from 15 to 18 to 21 is we went from 75 to 90 to 100. And if you look at 24, all we do is now we say, well, we've already got 100% of the lights are high efficacy. Now let's start dialing in what is the wattage associated or the amount of power that we're putting into those systems, right? And so that concept that the bulb has been taken care of is obvious. But now we get into the thing that really gets people's attention, right? In the energy code, in the 21 energy code, we start to talk about controls, right? That's that thing that, wait a minute, what we're doing what? In the 21 energy code, we're saying that building owners, homeowners, should exercise a level of advanced control over their lights. I know that's gonna send some people over the edge, but that's what the 21 does. It comes in and says that when we have permanently installed light fixtures, they have to be controlled by either a dimmer or an occupancy sensor or other control that's installed and built into the fixture itself, right? That we're going to have some functionality that says I can not only do I have the ability to turn on and turn off my light, but now I can reduce that power or reduce the amount of light I need by the use of either a dimmer or if I'm outside. Let's say I've talked about her before. I love my daughter, my princess, but when she leaves her room, guess what? After 15 minutes, she's got an occupancy sensor and it turns off. Why? Because there was a level of control I wanted to exercise over that environment that said, you know what? It's not good enough to just yell, hey, did anybody turn the light off? It needs to be the light will turn itself off, right? I have a utility space in my home, and all the time, whenever somebody goes into that room to get into the crawl space, they come out and they don't turn the light off. I don't know why. And so I'll come downstairs and I'll see the light glowing underneath the door. Why? Because it's on. And so having certain controls like occupancy sensors can really cause us to use less energy and conserve more energy, right? By having that. I do the same thing when it comes to my dimmer, right? If I'm sitting in my living room and I want a little bit of light, I have to turn the light in the kitchen on and it comes on full just so I can have a little residual light in the living room. It'd be a lot easier for me to go out and just buy a dimmer, which again, that's not a project for someday, right? To go and buy a dimming switch, and then I can dim my light in that living room and not spend as much energy lighting up 7 bulbs in my kitchen, right? For the 2 bulbs in my living room. So again, that's what we're seeing going on, is that we're installing interior lighting controls in the 21 energy code. And so what that means is I, as an inspector or as a building official, am now looking at that electrical drawing and saying, okay, I saw where you had a 3-way that connected these, but now I need to start seeing a dimmer, right? Or I need a note that says all receptacle lighting controls. All lighting controls shall be dimmers or shall incorporate a dimmer, right? You can still have 3-way switches. You can still have that ability, but you're going to have this dimming capacity so that people can control the amount of energy. Now, does that mean people are going to use it? That's not what the building code is about. The building code and the energy code is about giving people the control over their own environment. And again, that's where we have that flexibility to say, look, I'm going to use these, I'm going to install these things, knowing that you're going to use them, or potentially you will use them to control your own energy, right? To control your own destiny. And again, that's what we're looking for. We're looking for some acknowledgement, either in a note that a lot of times I find that now after so many plan reviews based on the 21 and now the 24, that's the note I see on the electrical drawings. When it comes in, it says all in the electrical note sections on page 2, it's going to say A1.2 or A01.2, whatever. It's going to say all lighting fixtures to be on a dimming control. Or I'll see where it'll come in and say, okay, we're going to have occupancy sensors in these rooms. Now, because one of the things the code does is it says you can have an occupancy sensor. However, what it also does, because every good code does, gives us some exceptions. And it says that if we have a bathroom, if we have a hallway, we have exterior lighting fixtures or some other lighting design that's used for safety or security, those 4 instances, we get to be exempt from those interior lighting control requirements, right? Because what we're doing is we're saying, when you're in the bathroom, you may be there longer than maybe the sensor wants you to be there. If you're taking a shower, right, and you're inside the shower stall and you're taking a shower, which I don't have to do my hair anymore, but when I used to do hair, right, I would be in the shower. The potential is there that light could turn off, and that would be a safety issue, right? not just a little inconvenience if you lose all the light while you're doing your hair and you can't see and you got to wiggle around. And so we make that exception. Same thing with hallways. When we talk about hallways, remember, we're talking about uh, both residential, single family story, single family, multifamily residential, as well as those R2s, R3s, R4s, 3-story and less above grade. Because remember, that's within the context of what the residential energy provisions address. And that's, so when we start talking about a small hotel or a motel or a dormitory, and they've got these hallways, what we don't want to see is that, again, where we have uncontrolled or inconsistent lighting conditions. We'll have a picture on here in a little bit later where we see it again. Well, actually, let's just go straight to it. When we think about lighting systems, right? Don't I have one? There it is. When we think about lighting systems, we see the same control requirement in the commercial side. But what we don't want this to do is be a horror movie, right? Where when I'm in the hallway and as I walk, each section turns on different as I approach, right? And then at the end, I've got a zombie or a murderer down there at the end, right? Jason's down there waiting on me. And so we don't want that to happen. We want a uniform reduction of light when it's not being used, but we still don't want it to become completely dark. We don't want residents to be unawares that there could be other security issues in the space, right? And so again, that's what we're looking for. That's one of those exceptions that the code identifies, is that if we're in a hallway, we don't need it. If we're in a, whether that's a corridor or something like that, where again, we're having consistent light so we can egress. Not, well, I have to wait. Somebody move your arm. So, because again, if this was a fire scenario, let's just say we're in a fire, and depending on the type of occupancy sensor or controls, we might not be able to that sensor may not be able to see us through the smoke as we try to traverse this egress path. And so again, we need to have constant, consistent, uniform lighting in these types of areas. And again, like we said, there's a variety of different resources, technology that are out there. This is not just a dimmer anymore. The potential is there for new construction for people to have those Nest systems, the computer driven, the iPhone based, control over their environment. And so again, all we're saying is you got to start out simple, put an occupancy sensor or a dimmer into that design. Now, again, we talked about detached before, or exterior lighting. Remember, exterior lighting in the 21 is exempted for single families and 2-family dwellings, because again, it's more of a conversation about how do we deal with commercial applications like a parking lot associated with a multifamily. And that's when, again, it shoots us back to C405.5. So again, we're not there where we're saying, hey, what kind of lights do you have outside your house? That's not the intention here. What we are trying to say, though, is that we want, if there's going to be lighting associated with a multifamily, R2, R3, R4, a hotel, motel, or just living facilities, those kinds of environments, then again, we're going to have exterior lighting, and we're going to think about those in that context. We talked about that a couple months ago. But again, single family detached, exempt from the exterior lighting controls that we see and calculations that we see in the code. But again, for those conversations, which we'll probably talk about again, in that when we require those exterior lights, we want them to be able to be turned on and turned off, right, by some type of a switch. And that switch or that capacity also recognizes when the sun is out, when it's daylight, and we don't need those lights on. So that when we do have an override capacity, that it has a reset. Because what we don't want to see is, again, that we've got these timers that say, hey, we only turn on at dusk, we turn off at dawn, right? That or they're on for so long after a door has been activated, right? We see all kinds of different layouts. The code is not about giving us those specifics of every design has to match the cookie cutter. What it says is here's the consideration and allows us to be flexible on how we meet it, right? That we have the ability to turn it on, ability to turn it off, that we don't turn it on, that it's not naturally on during the sunlight periods, and that we have some type of override capacity. that resets. Because what I've got a friend who runs a hotel, and there are times when he shuts off the exterior lights on purpose. He overrides those exterior lights to have a movie night or for the fireworks at the 4th of July, right? And so he deactivates that, but he doesn't have to come back and reactivate it the next day. It resets automatically, right? So he has that capacity, that control for that type of operation. It is not for our general residents. Now, I wanted to bring this up because I know you guys work very closely, and you have some designers that work and contractors that might cross the borderline. So if you don't want to hear it, close your ears, right? But I wanted to really quickly, because it's a big issue that we're having a lot of conversation about and surround in your neighbors to the west. And that's their energy code incorporates section R404.4. You do not. The 21 code does not. The 15 does not. The 2018 does not. The 2024 does not. But they've incorporated into the New Mexico, did I say Minnesota? The New Mexico edition of the energy code. They've incorporated electric vehicle transfer infrastructure. So I just want to make sure we're clear that sometimes if we have a contractor that's going to operate in both sides of the Panhandle area, they may come across this issue and they may say, well, do I need to have this EV charger? It is not part of the building. It's not part of the traditional normal 21 energy code. It is something Minnesota added, or not Minnesota, New Mexico. I said it now. Now my brain's going to go there because the initials, right? But New Mexico requires that as part of their energy code for residential, that they put in a single electrical receptacle in an attached or detached garage with a 50 amp breaker tied to it. That's for future EV charging equipment, right? It doesn't say you have to put in a charger. It just says you have to put a cable, and you have to put a conduit, you have to put a cable, you have to put a breaker, you have to put a box, right? And so again, I want to make sure that we understand that in your neighboring communities, they may have an additional requirement in the energy code that we do not have in the traditional 21 energy code. And they also do it in the same section for their commercial code. So again, not part of this requirements. That's why I made sure I put this little symbol down here. This is a New Mexico requirement. This is not an energy code requirement. So just be aware if you have contractors, because I know that you have contractors, some that go south and some that go west. And so I want to make sure that if they come up with that question, you know why they're asking it. So digression. What they'll normally see though, for those that do have it, is going to be, again, some kind of EV infrastructure. There's going to be a box. It's going to be on the plans as an EV charger with, again, some kind of a note that says, hey, provided charging rough-in, which means a electrical box, a raceway, and a breaker in the panel, right? So again, that's what a lot of that you might see, or again, if you got designs that cross those lines between the states, you might see that, and that's why. And again, like this one here, it came under energy efficiency, and it's like, well, that's not in our code. That's why, because it is in the neighbor's code. And I don't know if you guys get that as much as I do. I get all the time where a design takes over in one jurisdiction or starts to become popular in one jurisdiction, and then for some reason it just kind of translates over because the builders are used to it. They start doing it this way, they're going to do it this way. Production builders are the same way. They get into this is the model we're building now because we've priced it, we've got all the paperwork, and so then all of a sudden it's like, well, that's not required. Oh yeah, that's because it's not required here. It's required somewhere else. Digression. So with all that, if there's any questions, just make sure if you have questions, pop them in the chat, raise your hand, jump on a Q&A, and we can ask questions about the residential side. I'm going to start going into the commercial side now, so we can kind of have that conversation. But if there's a question that pops up along the way, make sure you let me know. So with the commercial expectations, because remember we said generally when we talk about commercial, it's defined as anything that's not residential, which means those R2s, R3s, R4s that are 3 stories and less below grade, those would be residential buildings. And So a 3-story hotel is a residential, but a 4-story hotel is commercial, and that causes some frustration, confusion. And so when we start talking about those 3-story, you know, dormitories or motels, they still, even though they're identified as residential by the energy code, they follow the commercial provisions, which means they'll follow the same concepts when it comes to um, compliance paths, right? A prescriptive path, a total building performance, right? Prescriptive, follow the tables. Right there you see dwelling units, sleeping units. In an R2 shall be deemed to comply with section R406. Again, 406 takes us back to um, the residential provisions, and when we start talking about ERI paths and stuff like that, we have the total building performance. Again, that's that dollar value calculation of how much does it cost to operate, right? That's C407. And then we also see ASHRAE 90.1, which I think I've got a couple examples of how ASHRAE compares. But ASHRAE 90.1 is a completely different standard than what we have in the IECC, but it provides similar expectations. So again, when we're looking at it from a commercial perspective, if you were to compare this in the residential, let's do that real quick. These two concepts, residential, commercial, look very, very similar. It's follow the table, be prescriptive, or it's go with some performance to calculate how much it's going to cost to run this building and compare those two options. When we look at what the commercial provisions expect out of our multifamily dwellings, our R2s, R3s, R4s, or any of the requirements of the commercial code, it's asking us for some very specific information. Again, it's asking us for lighting considerations, lighting controls, and lighting power for both interior and exterior applications, right? So it's asking how much energy are we using for lighting. Now, when we get into a data center, it's going to remind us that we divert or convert over to the ASHRAE 90.4 for the section that is data centers. But again, that concept's becoming a huge topic too. When do we have data centers in a maybe a hotel or a motel or a condo association, right? Hey, we're gonna have a big data center here to help make the internet work faster. And so data centers, a concept, is becoming more and more unique. It can be small, it can be big, it can be anything in between, right? But again, it provides us a reminder that for dwelling units, again, the primary expectation is that 90% of those luminaires, those lamps inside those units are going to be high efficacy. Again, it's a little bit more relaxed than what we see in residential in 21, because we're going to 90%, right? But it gets into a little bit more restrictive, because it tells us that we have a lumen to watt ratio, right, that we have to think about. So again, it gets very complicated at times, and so that's why it's important, I think, to show both sides. The residential that follows single family, multifamily townhouses, and then you have these R2, R3, R4s that we normally would have addressed through our residential provisions of the energy code. Now we have to jump over to the commercial side to look at their lighting expectations. So a dwelling unit in a condo would require 90%, but maybe not. But then they're also going to have some other expectations associated with them. Hopefully, I didn't just confuse myself for yourselves. But again, that information that's supposed to be provided as part of that commercial application is going to be very similar. We're seeing a lighting fixture schedule. We're seeing a control narrative, and we're seeing what's called daylighting zones. Now, this is for all commercial, including those buildings that follow under the R2, R3s over 4 stories. But remember, what we're looking at is there are in section 405, we are addressing the lighting requirements, not the thermal requirements of that design, right? So if we're calculating how much power is associated with the lighting, not if we're using electric heating, which is, again, an interesting way to look at how the code is balanced. If we're looking at how much, we never ask how much energy is being used for heating. right? We ask about the efficiency of the equipment that might be utilized or the controls that are associated with it, but with under the mechanical provisions. But the only question we ask in electrical or power and lighting, in electrical power systems, is the lighting side of it. And so, if you remember a couple months ago, we talked about the exterior. These are those sections that we find in the code associated with the exterior lighting controls and requirements, power allowances. Here's what we find for the interior, right? Our lighting for dwelling units, our controls, and our power and lighting calculation. Now, one thing I'll tell you now, I normally look first for the power lighting allowance calculation, right? How much power are you supposed to be using in that design? Then I look for controls, because again, that's part of what we're supposed to see in here, those controls, those lighting narratives. And once in a while, we'll see that show up in the form of some type of a ComCheck report or some other evaluation report. One of the things that a lot of times I see is the ComCheck electrical report, because it's a very simple, systematic way to review it, to outline what's going on in the building. Well, let's jump into this a little bit further. And if you have questions along the way, always ask. So remember, we're thinking about what's that root expectation associated with lighting in the energy code. Is we say that there's a certain amount of general lighting that we expect buildings are going to be using, right? And we need to make sure that it meets or is less than that maximum allowable power that we allocate to the lighting systems. Again, we're not saying this is the size of the service. We're saying this is the lighting, the capacity of the lights within that design. We jump into the code jumps into sleeping units, and again, it tells us what those expectations are. Very similar, we're having that automatic shut off. We're having that occupancy sensor that says, hey, if we're in a sleeping unit, we're in a hotel. A new hotel should have the ability to say, hey, lights are out if we're not using them, right? After we've left the units, you'll see sometimes you have that card that goes into some lighting facility, some types of hotels and motels. Again, what we also see is again, there's an interior power lighting associated with that design. Same concept for general lighting in non-residential, non-dwelling unit, non-sleeping unit, commercial, right? How much general lighting are we using? We're not asking who plugs in a lamp at their desk. We're saying in the building, we've structurally installed lighting systems. What is that capacity? So that we can provide uniform illumination across the building. It gives us, so after we understand what we're looking at, which we're just looking at general lighting in most buildings, most commercial buildings, then we ask the question, how are we controlling that light? Now, I like to jump to the end of it first and say, how much? Okay, so you told me what I'm looking at. Now I need to know how much of it, right? Well, let's just do that. We'll jump straight to that section, because I'm in charge of the slide. So I want to go to that section. And so when we get to that question, one of the things we start asking is, again, we get these sometimes in ComCheck reports that say, hey, this is how much exterior light versus interior light we're seeing. So remember to always check exterior versus interior electrical lighting. But when we look at it, the code tells us that we're going to calculate for the interior lighting systems how much is the allowable power density, right? Lighting power density calculation. And we do that based on either a building area method or a space by space method. And so again, we'll see that in different ways. But what ultimately it's asking us to do, let's look at the building area method first. It's saying, look at the building, determine what type of area you're looking at. So there's a table that gives you a variety of different types of buildings, right? Automotive, office, retail spaces, those kinds of things. And then there's associated with that type of building is a watts per square foot for lighting power density. What it says to do is determine which one fits the building. Let's go up here and pretend we are looking at the courthouse, right? Or an office building. Calculate how much square footage is inside that lighted area of that building. multiply the two, which makes sense, right? So I know I've got a 5,000 square foot building. I'm going to multiply it by this number because it's a hotel or a hospital or a courthouse, whatever that number is. And then once I've multiplied it, then I've got how much power I'm allowed. Simple math, right? I can trade off that power across any of the interior lighting zones, right? So if I've got a building that has, maybe a courthouse here and next door to it, which would be weird, next door to the courthouse is the Taco Bell, right? So I've got a retail next to the courthouse. I can calculate those and have them share across that interior lighting allowance, right? That's very similar to what we see in the next section. So, but let's finish up with this building area first. So if I've got this example here, which is a convenience store, and I go to this convenience store and I see it's a retail space, and I see I'm allowed to have 0.84 watts per square foot. I take the 6,000 square foot of 6,137 square feet of the sales area, right? I multiply it by the 0.84 and I get 5,155 watts of power. That's how much power I can use for lighting. If I compare this to ASHRAE, and again, I know we talked a little bit about ASHRAE. ASHRAE has 3 ways to check it out, right? IECC says building area, space by space. ASHRAE says simplified method, building area method, or space by space method. I'll show these real quick and by example. They're almost identical. Let's put it that way. Simplified, they go in what they've done in ASHRAE is they've said, okay, we've only got 3 types of building we're going to put in simple. These are simplified buildings. So you've got offices, retail spaces, and school buildings. That's it. Those buildings each, this one here is for office buildings. There's certain things, functional spaces. They get this much power per square foot. Here are the controls we're expecting with each one of them, right? So if you notice, it's 0.7, 0.7, 0.7, 0.7. Why? Because it's simple. We're not going to argue about whether or not this is an office or a desk or a stairwell. Nope. It's in an office building. We're giving it you want it simple, we'll keep it simple. When we look at our retail space, is for that retail building, see the sales area gets 1 watt per foot. Now, if you remember, the right? And so I get 6,006 watts of, right? Ability to have very simplified the basis of the parking garage stairwells, and we're supposed to do this. Was I kicked out? That's never good. That was weird. I apologize for that. We will keep going. So anyhow, so if I use the ASHRAE system, then I get this. I can sometimes use different mathematics, different ways of calculating what I'm seeing in the building. I'm gonna chat back open. Okay. And so again, now, like I said, ASHRAE has, so that's simplified. ASHRAE also has the building area, which if you look at it, 0.84. So we're getting the same value, whether we're looking at when we look at it from a building area method from ASHRAE or IECC, right? We get the 0.84, 0.84. So the math is right there. It's just in that simplified that we get there's a little bit of leeway. But again, that's how we calculate the building area. Look at the whole building and say it fits this box. This is what we're going to go with. And then we just do the number by number calculation. Space by space is a little bit more technical. We start to jump into the actual parts of the building and say, well, if it's an audience seating area in a gymnasium, you get this much light. But if it's in a church or a religious building, you get this much light, right? So again, we get very technical on what we're starting to actually calculate. Is this common space? Is this office space? right? We get into these little bit more specific expectations of how much light do you need in a movie theater versus in a gymnasium, right? So that's when you go that space by space. Now, what we'll see sometimes is even when you might be encouraged to use the space by space, some projects still go with a simplified method, right? Because they're looking and saying, hey, we're going to look at this whole school as an office, because even when we do the office calculation, we get 15,000 watts of power. We're only going to use 8,000. So why go through the space by space method? We could just use the building area method, right? Keep it simple. But if they wanted to use that again, space by space, they're doing the exact same thing in the map that we saw in the building area. They're determining which one applies for how much square feet or floor area is in that specific area, right? If I'm looking at it from a break room versus a computer room, right? And then I'm going to multiply that square footage by that number and then get to the final calculation of how much energy can I use for lighting in this entire building. So again, it's a very simple mathematical calculation to show this how much lighting power I can associate, or how much power I can associate with the lighting in the building. Now, when it comes time to demonstrating this, I guess I'm going to keep going. The code also identifies the ability to have additional interior lighting power when we have certain types of functions like retail spaces, or maybe there's specific task lighting associated with it. If we've got workstations or something that has extra lights, then again that light can be calculated as additional area, right? And the code gives us some options, equations to calculate that. What I see more and more is because of the technology, because a lot of these things are using LEDs, they're not coming close on even the front, the simplest of math, right? If I get 15,000 watts and I'm using 8,000, why am I going to go through the process of adding more lighting availability to me? I've already got all the lights I need, so I'm good. And so a lot of times you'll see that it might show up in a com check, it might show up in a plan, but more importantly, this gives them that ability to get more light, more power if they need it. But I rarely see anybody needing it anymore, unless you've got a really highfalutin type of lighting system. Now, what I will remind us when we start to review these com checks for lighting, interior lighting, verify the code here, right? Always double check the code, because you'll find out every once in a while you're going to get the wrong code, right? This one's giving us the 24 Minnesota Commercial Energy Code. Well, guess what? We're not enforcing that one. So we're going to have to say, hey, you picked the wrong book, right? We're going to verify the type of lighting. You're telling me this is a retail space, and then when I look at it, it's a jail. No, they don't match quite the same. We want more light in a jail so we know where everybody is than whether or not we can find the Twinkies. Although I think finding Twinkies is pretty important at a convenience store, maybe. So, and then we'll verify that after we've verified the code, we verified the right type of area, then we're going to verify the compliance, the number of fixtures, and whether or not it passes. Here we see this design passes by 49%. And so what I do to verify that lighting, right, whether I get this as a res check or a com check, is I'm going to count the number of fixtures, right, that are identified. I'm going to zoom in here. Identified on that sheet. I see right here I've got 43 items listed as pendant lights, right? And I've got a list of pendant lights here where I've got, what have I got here? 33, 44, right? So I've got 44 lights listed in this pendant section. Now, I'll be 100% honest with you. I'm not really happy about having to do that kind of, even that simple math. If I'm judging what's a pendant, what's a in ceiling, right? I'm probably going to say, I'm probably have some kind of a comment that comes back and says confirm the appropriate lighting identified in the com check is reflected in the fixture schedule, right? They end up sending this one back and saying, oh yeah, we messed up, and here's the whole list. T1, there's 26, 24. you know, they're whatever, they're going through and they're listing all these individual fixture names in this retail space to make sure I can do the numbers. But ultimately, what I find is there's 118 fixtures identified on this. Let me do this. I gotta go back. There's 118 fixtures identified in this ComCheck. Well, there's 225 fixtures identified on the schedule. So you may not be as close as you think you are because you've only calculated on half the fixtures. So again, I'm not going to recalculate everything. I'm just going to say, hey, you added 118 fixtures to this simple math calculation, and you put 200 over here. They don't appear to match, to be consistent. Appears to be some inconsistency in the number of fixtures identified in your ComCheck lighting certificate and your fixture lighting schedule on page E101, right? That's the kind of comment I would put and to kind of give me the right information. When you apply it in the field, again, we're going to be looking at those same designs and we're going to be saying, okay, does this match? It's 24 code. Nope, I'm a 21. I'm looking at this for the 21. So that means I've got the wrong calculation because this calculation shows a convenience store sales area at 1.10, whereas my code says 0.84 watts per square foot. They're going to be off. I'm going to verify all these things. And again, I'm going to be looking at everything that's in that plan review. I'm going to get this ComCheck page and I'm going to say, okay, what do we have in this facility that matches with what I'm seeing? Now, knowing that all that's there, and again, we talked about the exterior lighting in the same concept there before, but knowing all of that's there, I'm going to jump back up to my lighting controls. So now I know how much light, I know what I'm looking at, I know how much light I'm allowed to use. I've got the right number of fixtures in place. Now I need to control it. And in all reality, we really have three types of controls we look for. We look for occupancy sensors, time switches, and daylight responsive controls, right? If there's specific application controls because you're using a specific type of material, that's going to be identified and exempt from these as long as they're controlled by the right piece of equipment. If we have exterior lighting controls, that's for exterior lighting, right? We're doing interior lighting. And again, what I'm looking for is I'm going to have some type of occupancy sensor that says, hey, when someone's in their office, the lights are on. And if I've got 32 offices here and half the people aren't working today, I shouldn't have 32 lights on, you know, assuming that each of these rooms gets its own individual lighting control. What the code says is that occupancy sensor controls are going to be in all of these office spaces, right? And basically what we're looking for is anything that's going to be 300 square feet or less, right? We're not looking to control the entire building off of one occupancy sensor. If I think about, you know, where, and I'm gonna use Guadalupe's office, you know, if I think about the entire bullpen that you have associated with your plan review team and your inspectors, that's not on one occupancy sensor. That just wouldn't make sense, right? Maybe Johnny's office is on an occupancy sensor, so when he's in there, the lights are on. When he's not, it's off. That, you know, those are going to be things that might exist that we'll see on a plan. And that's where it's important to understand what we're looking for, right? If it's a small room, we're going to have an occupancy sensor. If it's a big space, then we're going to expect to have individual occupancy controls. This control will control this 600 square feet or up to 600 square feet of space, right? It's going to have that functional capability to just shut off after 20 minutes or so, right? To reduce power when nobody's there. Same concepts in these bathrooms, right? These bathrooms are going to have occupancy sensors because that person will be able to activate that sensor in this layout, right? Same concept. So if I can be in this room, if I move around here, these lights will be on. And when I cross over, these lights will turn on. One of the reasons this is important is because we're going to see these different functions and these different controls, they're identified different ways. This is one of the reasons why I don't think AI assisted plan review is really going to happen for a while, because I've seen them call them OS. I've seen them call it just put a occupancy sensor in the description and just use a normal S for a switch or a symbol, not even letters. And so again, it's going to be something we have to pay attention to every time we do a plan review to figure out where is the ceiling mounted occupancy sensor if we have one. And then not only that, but how is it being controlled? Is it turning on, turning off? What's the timing period for that? So again, there are certain things that we need to make sure that get, as an inspector, I'm going to be looking for, or as a plans exam, I'm looking for, so that the building is going to operate efficiently. One area that again, we have some functional changes to the occupancy sensor is going to be warehouses, because we want each aisle to be controlled independently. We don't want, I walked into aisle 3 and aisles 4 through 57 all light up, right? We want to make sure that we're using efficiently the lighting we need in these areas. And then we also incorporate things like time switches. Again, not everything is going to be occupancy sensors, right? We're going to have some times, and we see here that it reminds us that we're going to be using that control for only 600 square feet. Again, not the entire building. And that's going to turn off when no one's in the room, right? It's going to reduce and have a timing period so that we're not having this constant on and off, every time I move my arm. But again, thinking about these designs, one thing I usually say is when we start talking about these types of considerations, I'm looking for some signal that the designer has thought this way, right? That they've identified that this control runs these lights. That tells me right off the bat they've thought about control, right? I'm not, again, I don't spend 6 hours doing lighting control for energy compliance, right? If I'm on it for 40, 45 minutes, that's normally more than enough time to figure out, did you calculate the lighting allowances? Did you have the right number of fixtures to demonstrate compliance with that lighting allowance? And then what am I seeing for controls and the location of those controls, right? I'm not going to double check that. At least at plan review, I'm not checking, does H connect to all of these through a wire, right? That's going to be an inspector's job. I'm going to say all of these systems, all these lighting fixtures go off of H. So when you can test, you have that functional testing and say, hey, turn on the lights. And they all turn on based on where I'm standing, right? And like we said earlier with the corridors, when we don't have occupancy sensors, that's when we're going to require time switches, right? Something a little bit better than our time dial, right? There's certain functional capabilities that these lighting controls are going to have. The code that provides that information tells us when we don't need it, certain exceptions and exemptions that exist based on size. Because again, what we're trying to say is if it's not based on when people move around, it at least be based on when people should be here, right? Monday is a holiday. So some systems, if they're not properly wired, will turn on the lighting systems. We'll turn on the HVAC system, despite the fact no one is going to be at City Hall, right? I worked in a business. I worked in an office at the county building. When during COVID, I use this, I sometimes bring this up. During COVID, I kept going to the office. I was the only one who went to the office. And at first, that first 2 weeks, I did not, right? And then I realized I went in there for something. I needed some file or something for work, and the heat was on. The lighting controls were on. The lighting wasn't on because our lighting is based on actual occupancy sensors and manual controls for some of the corridors. But the heat was on, and I thought, wait a minute, we're heating the building? Oh yeah, because we don't use a smart system. We use an old system that's got a dial, and so it turns back the system. The clock. We got it. And so again, the building's being heated, the building's being cooled, the building was being powered, despite the fact that everybody was home. Same thing is probably going to happen Monday. There are going to be buildings that we know will be open, all the lights will be on, and nobody will be home, right? Because of this type of control. And that's why we start to address it now. Build into a building the things we want it to do, right? We want to make sure buildings are conscious of this and have the ability to control for this. right? And again, that we have these new types of controls. Light reduction, same thing. Dimmers, we see they can dim the individual light. They can dim a variety of different things. The code does not get into, you know, how you dim. It just gives you the ability to reduce, right? And same thing with same concept when we talk about daylight responsive. What the code is really getting to, and I know we don't have very much time, when the code gets into daylight responsive controls, which if you have questions, we can always talk more about, is what it's really looking at is if I'm getting natural light through a side window, through a vertical fenestration, it tells me how far that light will extend into the space. And whether or not the question becomes how much artificial light is inside these primary and secondary side lit zones, right? Secondary side lit zones became a thing in the 21. Before that, we just had primary side lit zones in commercial, right? You get 1 times the height, half a height the side laterally. And so what we're saying is if I have 150 watts of power inside this zone, then I need to control for it. I need to have a daylight responsive control. One thing I never get is this kind of information. I always have to double ask for this information. Same concept with top lit, right? If I got a sunroof, which a skylight, which we know is required by the code for certain size buildings, then you're going to have areas that are affected by the sun's natural light. So then in these areas, this 70% of the ceiling height area, this daylight zone, if you've got more than 150 watts of powered light, then you need to have a control that says, hey, when we have sunlight, we don't need to keep the lights on. Right? We see that again in another orientation. What I don't see a lot of is this kind of a diagram, right? I like it when I read a note that says, hey, we've calculated, here's my daylight zone. We have one, but the lighting inside it does not meet 150. So I don't have to, I'm exempt from daylight zones and daylight controls. I don't have enough lights in there. So I don't need to do it. Beautiful, beautiful. I love it, right? I also will get it once in a while. It says, no daylight zones provided, right? If the windows are too small, we're not getting natural light, then just tell me that the window sizes you've chosen do not provide natural light into an occupied space. I'll take that as a note so I don't have to ask you where the daylight zones are. And did you calculate the power consumption in those daylight zones? We're asking for that information enough. People get, at least in my design, in my plan reviews, we've gotten to a place where people have said, hey, we don't have any daylight zones. Okay, I'm trusting you. You want to lie to me? We'll talk about that later, right? Because that's going to affect what my guys are going to be looking for when they go out in the field. And again, that space, and again, like I said, in the 21, we expand it from this the primary to the secondary zone. So again, we calculate the 150 in the primary, 300 over the 2 zones in order to decide who has to have those daylight responsive controls. And so like this one here, use this example. We got 1 minute left. I can see where their occupancy zones are, their occupancy controls are. But when I look and see they've got skylights, I have to send them a letter. I have to send them a comment that says, hey, specify that skylight, the daylight responsive zone associated with these skylights as required, and the associated daylight responsive controls for that top light zone, right? I'm looking for an email or a response that says, hey, in these zones, we don't have enough light, right? We've got 2 lights in this zone. We got 1 light in this zone, or something. We don't have enough lights to justify the responsive controls. Great. I need that information, or else my guys are looking for some type of a lighting control. I know we ran out of time. If you have questions, obviously I'm here. I do want to let you know next week is the Bring Your Energy Code questions. And if we don't have a lot of questions, we'll probably talk a little bit about, some software options that are out there. That's kind of where I'm kind of pushing that conversation if we don't have questions. But then we'll get back in early June for those plan review conversation and the inspections associated with power and lighting. We did cancel the webinar for the 19th because of the Juneteenth holiday, but we are going to get back together on the 26th to have that plumbing conversation. And for those of you that don't already know and haven't received notice already, we are going to have an in-person training in Amarillo on the 20th, Friday the 20th from 9 to 4. It'll be an in-person on plan review for residential projects. We're going to be looking at the entire process from start to finish, from foundation to final CO, right? Or not CO, to final compliance, right? To final code compliance, certificate stamp. And so we'll be looking at all the systems and having a great conversation along the way, looking at small residential, large residential, mixed family, multifamily structures. If you have a question, feel free to email, register, to reach out to Hope or I, so we can get all that, any of your questions answered. If you have a topic that you think would be useful for us to start to bring up, please, please, please use the survey this week, because we're going to be using those surveys. I'm going to go through tonight, this afternoon, and finish and start doing CEUs and evaluating all of the different surveys for the next couple of trainings. So if you do have questions, feel free to put them in there so we can get those answered. Again, we have the helpline. If anybody has a question about an energy code and wants to send us a question, or if there's something that your contractors have questions on, always feel free to send them to us if we can be a help to them. We can do that for free as part of our projects. Always check out the website, find different information. And as always, like I said, if you have questions, reach out to us. At a minimum, I'm hoping to see you guys all in June for our in-person training. And I'll probably be doing some running around that week too, to kind of just say hi and visit some contractors. If you do have contractors and designers that you work with and think would benefit from talking about plan review, please invite them to join us on that Friday so that we can have a good conversation. And lunch will be provided. I don't know if it's going to be pizza this time. We might try something different, but we'll see. We'll talk about that when we get there, before we get there. Let's put it that way. You guys have a great week. Be safe. Be careful this weekend with the different celebrations and Memorial Day festivities, and take time to remember what we're celebrating. We appreciate all of you, and we will see you again soon.